In this video, we're going to apply exponential growth functions to real-life situations. One of the most common formulas that you're going to use in order to model exponential growth is the following: y equals a times 1 plus r to the t power, where this value a, this is your initial amount. So this is your starting amount of whatever that is growing. R is going to be the percent increase, usually per year, and T is time measured in years. And really the output here, y, is just the amount you have of that object or whatever is increasing after t years go by. So y, this is your final amount after t years go by. Alright, so let's apply that model to the following problem. It says internet hosts. In January of 1993, there are about 1,313,000 internet hosts. During the next 5 years, the number of hosts increased by about 100% per year. A. Write a model giving the number h in millions of hosts t years after 1993. And then about how many hosts were there in 1996? Well, we're going to try to use this formula, y equals a times 1 plus r to the t power. Now in this case, they want to give the number h in millions of hosts after t years go by, or after 1993. So instead of y, let's use the notation h. We're measuring in millions. Now, the starting amount, they do tell us in 1993, which is our starting year, there were 1.313 million internet hosts. Now this is, you got to be careful here. In this problem, my a value would not be 1,313,000. At least I wouldn't write it that way, because it does say h has to be measured in millions. So if you think about it, this is 1.313 million. So essentially you have to move the decimal place over, and instead let's use a as 1.313. So we're going to have h equals 1.313, that's our starting amount of internet hosts in 1993, and then 1 plus our rate that we increase by per year. Now r, we don't want to write as a percent, actually we want to write it as a decimal. So 100% as a decimal, you guys know, is just 1. So in this case, r is going to be 1, not 100. And it would be to the t power. So if we kind of clean this up a little bit, we're going to have h is 1.313, and then it's going to be times 2 to the t power. We just answered the first part of this question. That's our model that gives the number of hosts in millions after t years after 1993. Now for the second part, it wants to know how many hosts are there in 1996. So in 1996, our t value would be 3, because it's been 3 years since 1993. So if we were to calculate this, we're going to have h as 1.313 times 2 to the third power. So really, this one's actually not too hard to do without plugging in everything into our calculator, because we can raise 2 to the third pretty easily. That's just times 8, right? 2 to the third is 8. So I maybe would use my calculator to multiply 1.313 times 8. And if you do, I get 10.504. So h is 10.504. To answer the question, how many internet hosts were there? Well, remember, this is measured, oops, don't want to have that mark. This is measured in millions. So I would say in 1996, that's supposed to be a 96, there were, according to this model, about 10.504 10.504 million, remember this is measured in millions, 10.504 million internet hosts. Let's go do another problem. Another form, or another something we could do with these exponential functions is model money making or investments. So many people invest their money in different ways in order to earn more money. To invest money, you need to give up an initial amount of money that's called your principal, and you can't use it for a period of time. During that time, however, your money earns interest, which is a percentage of your principal that is added on to the initial principal. The formula that we use for these interest problems looks a little scary, at least initially. So we get A equals P, and then we're going to do 1 plus R over N in parentheses raised to the N times T power. This is the formula we're going to use. Let me explain what everything means here in just a moment. P, this is our principal. So this is our principal. So we have our principal. This is the initial amount of money that we invest. So think of this as your starting amount. R is just like what we had in the last problem. R is going to be your interest rate. Now the interest rate is going to be given in the problem as a percentage, but make sure you change the percent into a decimal. So we want it as a decimal in the problem. Let's talk about N real quick. N appears in two spots, here and here. N is the number of times that you compound your interest per year. So let's write that out and then I'll try to explain it. So N is the number of times you compound per year. So in these problems you can take interest on your money more than just once a year, which is kind of what you were doing in that last problem. We were only taking 100% of the internet hosts each year. Here we can actually apply this interest rate more than once per year. And we'll kind of investigate what happens as you do that more and more in an example in a second. T is still the time in years that we've had our investment invested, and A is our final amount. So this is our final amount after T years go by. So let's see if we can use this information to solve a couple of problems. In this next example, this is actually a true story. When I first got hired as a teacher, I took a CD out. It's a certificate of deposit. It's a type of investment at a bank for an initial amount of $10,000. So that's what I had available to invest. The terms of the CD were that I could not use it for 5 years, but in the meantime it was going to earn 4.25% annual interest each year on that $10,000. Let's find out the amount I would have in the bank after 5 years go by if the interest is compounded with each of the given frequencies. So for A, when it says you compound annually, that's really telling you about your N value. So if you compound annually, you're really only compounding one time per year. So in this case, our N value is 1. Let's see if we can write out the formula again, because there's a lot of stuff we have to figure out. It's A equals P, and then it was 1 plus the rate over N to the power NT. We already know we're going to plug in 1 for N. Let's think about P. P, remember, is our principal, which is our starting amount. And here, I started with $10,000. R is our interest rate. And in our interest rate, remember, it was 4.25%. Now, as a decimal, we would have to move that decimal point in that percentage over twice. So it'd be 0.0425. This is going to be the amount that we want to use for R. Then we have to write out, let's see, we know what N is already. T, I think we do know in the problem. It does say find out the amount you have after 5 years. So right there, we know our T value is supposed to be 5. I think we have everything we need in order to figure out the amount that I'd have. Let's see if we can simplify the formula, and then we might need to use our calculator to help us out. So we're going to have A equals, it's going to be 1,000, or excuse me, 10,000 rather. That was our initial investment. And then it's going to be 1 plus the interest rate as a decimal, 0.0425. We're going to divide that by n, which we know is 1. All of that's to the power n times t, which is really 1 times 5. Before we grab our calculators, let's see if we can clean this up a little bit before we make more work for ourselves. So we're going to have 10,000. And if you divide 0.0425 by 1, that really doesn't change this number, right? That's still going to be 0.0425. And if you add 1 to 0.0425, it's really going to be 1.0425. So our base is 1.0425. And if you multiply 1 times 5, you're just going to get raised to the 5th. At this stage, I would grab my calculator to type this stuff in. So I'm going to go ahead and do that, and I'm going to show you how I'm going to do that. Now I might lose some of my writing here, so that's okay. So remember, what we were going to try to type in our calculator now was 10,000. So we have our 10,000, then it was 1.0425, and we're raising that to the 5th power. Your calculator will know to raise only the 1.0425 to the 5th, and then take that answer and multiply it to 10,000. So if you do that correctly, we get $12,313.47 if we round to the nearest hundredth, right? We're going to go to the nearest penny since we're talking about money. So I'm going to go back to my slideshow, and I'm going to rewrite what we have, and I'm sorry, you hopefully have everything written down, right? My screen lost what I have. So that final amount was 12,000, uh-oh, I have to redo it in my other calculator here. $12,000 was 313.47 dollars. That's how much I would have after 5 years. I'm going to do one more, and then I'm going to have you try part C. If we're doing this quarterly, everything's staying the same except for if we compound quarterly, we're changing our n value slightly. If you compound quarterly, guys, it's like you know, there's 4 quarters in a dollar. There's 4 quarters in a game. That means we're going to compound 4 times throughout the year. All of the other values are the same. Our principal is still 10,000, right? Our rate as a decimal is still 0.0425, and the time is still 5. So in this case, what I'm going to have to type in my calculator to find my final amount A is going to be 10,000, and then it's going to be 1 plus the rate 0.0425 all over 4, remember that's the n value, to the power 4 times 5. Remember it was to the power n times t. Well, this is not very pretty. The only thing maybe I would do before I type it in my calculator is multiply the 4 times 5, right? So we're going to have 10,000, and then in parentheses 1 plus 0.0425 over 4, raise that to the 20th power. And I'm going to show you how I would type that in my calculator to have it do all of the work. So in my calculator, I'm going to type in the 10,000 once again, and now it's times 1 plus 0.0425. Remember, we're dividing that by 4, so I'm going to divide it by 4, close the parentheses, and raise it to the 20th power. Now the calculator will know the order of operations for that inside and divide the 0.0425 by 4 and then add 1, raise it to the 20th, and then multiply by 10,000. If you do, you get a pretty close answer to what you had before, $12,353.81, and we'll write that down in a second. So again, our final amount then was in dollars, $12,353.81. So it was a little bit more money because we're compounding more than just once per year. We're taking interest on that starting amount more than just once. Now for part C, I'm going to ask that you try this for one of your self-quiz problems. What if you compound every single day, meaning your end value is really 365. So you take interest on that $10,000 every single day, 365 days a year. What I want you to do is see if you can compute then how much money I would have if the bank were willing to compound daily. You might think it would be extremely better than if you just compound 4, but you might be surprised. So go ahead and try that for your self-quiz. And the last problem I would like you to try for your self-quiz is this one. See if you can do this one. By the way, this guy is very similar to the internet host problem, okay? So if you get stuck on this one, check out that internet host problem. Remember, you're going to start with the y equals a, then 1 plus r to the t power. This is not like an investment type problem. So just use this formula, and I think you're going to be all right with this quiz. Good luck, and we'll see you tomorrow.